Hello guys. Welcome back to another video. So basically, I aim to solve the ASREP challenge. So basically, I've been taking the incident responder part on LetsDefend, and I came across some challenges, right? Relating to Active Directory security. Okay, so I in this video I plan to take this challenge, that's the ASREP challenge, and then as time goes on, I would also be tackling the various challenges like the golden ticket challenge, order of enumeration, NTLM relay, Kerberos. So which relates to attacks that are indeed happening in real world scenarios. Okay, actively uh, actively exploiting vulnerabilities found within Active Directory environment. Right. So I would start off with the ASREP challenge. So since I would like to, most of the times I don't like to use the lab environment within the platform. So what I'm going to do is to connect, and then I would rather connect via RDP to the machine, or just to say out RDP into the machine. Right. So let me quickly spawn the lab environment, and as that's yeah, so as the lab environment loads, let's just look at what this challenge is about. Okay, so a network security team received alerts from a DC indicating that a user was making unusual requests for Kerberos tickets. Um, yeah, so I'll explain that, which is not typical for their role. Given that this behavior aligns with potential reconnaissance or lateral movements within the network, the security team escalated the issue to a senior investigator. The investigator has been tasked with analyzing the provided DC and then workstation logs to trace the attacker's movements, determine determine the source of the anomaly, and also understand how the attacker gained access and what actions they might have taken inside the network. So um, from this scenario, we've been able to understand what the challenge is all about. Okay, so we are actually investigating um, an unauthorized access, okay, into an Active Directory environment, right? And we have our challenge file to be within this location, so that after the lab environment has been spawned. And so whilst this lab environment loads up, I'll just take the opportunity to explain, a few things before we start off with this challenge. Because looking at this challenge, it is of much importance that you know what Active Directory is all about before you can effectively take this challenge, or even understand what you are actually doing, right? So if we talk about Active Directory, I know you've probably been hearing of Active Directory, and I know there are some people that might be watching this video now that know exactly what it is all about. Okay, but in the same way, someone might genuinely not even have the understanding about what it is or how it works. I'll try my best to explain it in the most simple terms I can, okay, so that we can be able to use that to solve this challenge, right? So when we talk about Active Directory, it is a Microsoft directory service for Windows domain networks. Okay, so it's just simply designed to basically answer some questions. Okay, so one question can be that who are you? So in terms of like authenticating a user, right? And then what is the user also allowed to do? Okay, what is the user authorized to do within the network? So think of it like authentication and then authorization. Okay, now aside that, okay, I think our lab environment has been found. So I would, let me just increase the extend the time so that uh doesn't pass out. Okay, so the machine's time has been extended successfully. So it serves like a centralized environment, okay, whereby sysadmins can easily manage authentication, authorization, okay, in let's say a huge environment with many computers, okay, many users, and everything of that sort. Managing each and every user, okay, or account becomes a challenge, okay. So that is just one way by which Active Directory helps out, okay. But then it can also be a single point of failure, okay. So in terms of if let's say a domain controller has been compromised, okay, it means that not just one computer has been compromised, but then lots of computers within the network, because this domain controller is has those privileges, okay, to manage all those computers within the environment or within the organization's network infrastructure, okay, in a centralized, kind of way, right? So that's just what Active Directory is all about, okay. But in order to explain what ASREP roasting is, I think I have an image. I have an image over here that will help me better explain it. Right. So yes. So let me try and then zoom in a bit. Okay. So before we talk about the ASREP roasting and then how it works, let's first treat how legitimate Kerberos authentication works within an Active Directory environment. Now you might be asking that what is Kerberos? Like if we talk about Kerberos as well, what is it? Okay. So basically it's an authentication protocol, okay, within an Active Directory environment. That one thing about it is that it has stronger encryption as compared to the older NTLM protocol. Okay. And then I think it runs on UDP port 88 as well. Yes. And aside that, you know, although I've talked about the fact that it has stronger encryption and then all that, um, it still has some kind of characteristics that allows attackers to abuse its trust. Okay, so the main thing about Kerberos is authentication. So do I trust you? Okay, what can you actually access? So an attacker can be able to manipulate that kind of trust within the Kerberos authentication flow. Okay. So let me zoom in a bit. Okay. So starting off with the first stage, a client. So let's say you working within an organization, okay, you want to perhaps access a file share, okay, over here. Now this is what happens within an Active Directory environment. So before you can be able to access this specific file share, okay, you would go through this process, right? So you first request a TGT. So we talk about a TGT, is simply a ticket granting ticket. Okay. This is requested from the authentication service. Now within the KDC, so the KDC is the key distribution center. Okay, it's one of the main features of an Active Directory environment. So within the key distribution center is the authentication service, and then we also have the TGS, that's the ticket granting service. Yes. So in the Kerberos authentication flow, before these clients can't be able to request a ticket granting ticket from the authentication service, they must first go through a pre-authentication stage, okay, or a pre-authentication um, um, has to happen, okay, before that client can request that TGT at once. Okay. Now what really happens here is that before a TGT is issued, okay, then there is the need for pre-authentication of the client, okay, done by the authentication service. One thing or one reason why this is being done is to kind of stop brute force attacks. So guessing of passwords, okay, so it is done to prevent that. Here the client has to prove that they already know their password. Okay, so it's like, oh, you are telling authentication service that, oh, I need a TGT, okay, but then you have to first authenticate that, I am who I say I am. Okay. So how this works is the client has to prove that they already know their password, okay, by encrypting a timestamp with a hash derived from that password. Then the KDC, that's the key distribution system, now checks that the decryption actually works. Okay, so you have told me that this is my password, this is the encrypted version of my password. Okay, so you try and then decrypt it and see. Once the KDC is able to decrypt it, it sees that okay, this person is actually who they say they are. Okay, so that's what happens during the pre-authentication stage. So that happens before finally that TGT is handed out. Okay, so now the authentication service verifies the user. That's the pre-authentication becomes successful and then issues the TGT with a session key. Okay, so it issues a back to the client. Okay, now this specific TGT, okay, that has been issued back to the client contains an encrypted version of the user's password, right? Then this is actually where ASREP roasting, takes place. But before we get into that, let's just try and then understand, the full Kerberos authentication flow. Okay, so after that TGT has been issued back to the client with the session key, which has been encrypted, the client now presents the TGT to the ticket granting service and they request a service ticket for a specific service. So perhaps I'm trying to access a file share. Okay, I need that specific service ticket to be able to access that file share. So that is what happens there. And now the key distribution center, or let me say the ticket granting service within the key distribution center validates that TGT, right? After validating that TGT, the client can now present the service ticket to the service server. Okay, so now after the TGT has been validated over here at step 4, the client now presents it to the service server. So if it's a file share, SQL service, anything of that sort, okay, it now presents that service ticket to the service server. Then what does the client get in return? So the client gets, so the service server now validates the ticket using its key. It establishes a session and then grants access. Okay, so a user must, this is how the Kerberos authentication actually works. So before this client can be able to access a service over here, it goes through the process of Kerberos authentication. Okay, talking about the key distribution system actually, right? So having understood that, we can now look at what ASREP roasting actually means and then how it works. Okay, so for ASREP roasting, remember I told you that there is the need for pre-authentication to happen before a TGT is issued. But for ASREP roasting, since some accounts, okay, may not be having pre-authentication enabled, or maybe they have the pre-authentication feature disabled, okay, which is likely due to maybe using legacy systems, or perhaps misconfigurations. We know that misconfigurations are one of the easiest attack vectors. Okay, so it could be that it was a misconfiguration on the part of a sysadmin, okay, and then an account has pre-authentication disabled. When this happens, an attacker can then request a TGT. So in this case, it doesn't go through the pre-authentication stage. Okay. It just requests the TGT for the user account that has pre-authentication disabled. Right. So once a request for this TGT, the key distribution center would not say, oh, okay, I need to authenticate you to be who you are, you say you are, okay, who you are indeed. Because there is no pre-authentication enabled, the key distribution center um, gives back or replies back with an ASREP, okay, which contains the encrypted part that has been tied to the user's password hash. Okay, so once the attacker has this information, the encrypted ticket and then the session key, since it has the encrypted part of the user's password hash, okay, the attacker can then you know, use this information or take this information offline and then extract the hash from the ASREP, okay, and then crack it offline, right? So because of the removal of pre-authentication from this specific workflow, the attacker is able to, you know, request for a TGT and then crack the hash that came along with it, okay, and then use that to now authenticate as the user they were trying to authenticate as. And then with this particular attack, it doesn't really need you to have elevated privileges, or you don't have to have special accounts within the network to be able to carry out this attack. Once you have once you have network access to the domain controller, that's just it. You can be able to carry out this attack once you have identified, or once an attacker has identified that there is an account without pre-authentication. Okay. Now, why does this work? Pre-authentication prevents the KDC from issuing. So this is basically what I explained earlier on. So if it is disabled, the KDC now sends the ads rep, okay, without verifying who the attacker is. Okay, so without verifying that, oh, okay, give me the encrypted version of your, password. Okay, if I decrypt it, I know that yes, it is indeed you, right? That step doesn't happen. The attacker can now take the hash offline and then crack it, okay, without even generating field login events. Okay, now let's go back to the challenge. So having understood that, let me quickly connect to the uh, lab environment. Okay, so I'm going to do that via RDP. We have our username to let's defend. Okay, so I've now connected to the device, right? Now let's read what we have. So this is the file location and the questions that come with it. So while reviewing the logs, Janice identified suspicious Kerberos ticket requests, potentially indicating an ASREP attack. What is the exact time this attack occurred? So one thing I need to touch on as well is we talked about how the attack works, and we also need to touch on how we can be able to detect it as defenders. Yes, so we've been able to identify how the attack works. Now, how can we be able to detect such an attack? Okay, that has been performed. Okay. Um, every Kerberos TGT request generates an event ID. Okay, so in a Windows environment, you understand that there are so many event IDs that even it becomes so much difficult to easily remember them without reference, right? But one event ID that will help us, I think, at least to start off this challenge with, since it's really associated with an ASREP attack. We are going to look at the event ID 4768, specifically looking at the domain controller logs, right? We'll focus on that, and so let me quickly switch back here. So I'm going to open the challenge file. I think we need to unzip this password infected. We are going to look at the DC logs first. So I'm going to open this in events event viewer. Should I store? Okay, yes. So what I was talking about was that to be able to identify any Kerberos tickets that has been requested for, we need to look at the event ID 47. We are going to filter the log for event ID 478. And since we weren't given any particular, or were we given? Let me quick check. Um, we weren't given any particular time that the attack occurred, right? So we can't be able to just filter for this event. So let me can see this task category is the Kerberos Authentication Service. Okay, so one thing about detecting ASREP um, wasting is that there might be legitimate requests, okay, as well. And then how do we try to differentiate between what a legitimate, TGT request looks like, okay, within an Active Directory environment, and then how do we also detect malicious ones? What we're going to focus on mainly is so you can see over here we have additional information that's in the general tab. We have the ticket encryption type that is 0x12, and then the pre-authentication type that is 2. So chaining these two with event ID would help us to identify when a malicious request for a TGT has been made, okay, on a domain controller, sorry. So what this simply means is um, if we see a ticket encryption type to be 0x12, okay, it tells us that that is a legitimate authentication request, okay, using AES 256 encryption, right? Then for any authentication type aside 0, so this one is 2, it also tell us that pre-authentication was indeed performed. But in the case where we have the ticket encryption type to be 0x17, it just tells us that there was an ASREP posted request, okay, because that is what would give us that specific ticket encryption type to be 0x17. That's using the legacy RC4 encryption, okay. Then also pre-authentication type would now be 0. Okay, so once it's 0, we know that there was no pre-authentication took place between the client and then the authentication service. Okay, so I think there are about 171 events over here, and I think looking through all these events individually might be a challenge. Okay, so we are going to utilize the find action. Okay, so I'm basically going to narrow this down to the ticket encryption type. Okay, so I need something as close to what 0x17 to be able to identify an ASREP roasting attack. Okay, so now once I used this action, I've been able to find one event. So a Kerberos authentication ticket was requested. Okay, and the account name was what Corrado um uh and there's some information about it, but let's just see what the additional information tells us. Now for this event you can see that we have the ticket encryption type to be 0x17. That's using the legacy RC4 encryption. So one of what I told you earlier on, that one thing we'll check out will be the ticket encryption type. So once it's not 0x12, that's using the legitimate or using the AES 256 encryption that a legitimate authentication request might use. It should help us raise some kind of concerns or suspicions about the specific event. Pre-authentication type was also 0, meaning that the no pre-authentication was performed, okay, for this specific event. The client address is, so this we can say that this was a network connection attempt, or the specific client address from which this TGT was requested for. And I think this is very very much useful. Very very we have gathered a lot of information, but let's see if there is another event. So let me use this. You can see that searching for the selected event to the end of the, so basically this is just the event, and then I think we are lucky enough to get just one event, so we can definitely say that this is what we are, so actually hunting for. This event is what will help us um, um, start off with our hands. Okay, let's go back to so while reviewing the logs, reading once again, Janice identified the suspicious Kerberos ticket request. So this is what we've been able to identify. Okay, so this is the suspicious Kerberos ticket request, which indicates an ASREP attack. What is the exact time this attack occurred? So um, the exact time. Let's see. Let's see. Let's copy this. Let's copy this and take note of the answer format. So it seems like it needs the year first, separated by hyphen. This could be the month and then the day, or the day and then the month. Then it also needs the um, hours, minutes, and then seconds. So let me indicate that we are going to remove the PM. Uh, this becomes let me use 10:05. Uh, submit this and works out. Okay, so it says wrong answer. So I'll swap out this. Let me make this 05 and 10 rather. And let's see. Okay, one thing I didn't add. So um you remember it was PM, right? And then let me go back. Mm, if I'm not wrong. So this happened, at 2 p.m. So I think I need to, change this to 14. It reflects that actually. Let me submit. So now it says that we are very close to the answer, and I think the problem might be that I interchanged the um, day and then the month as well. So let me submit it. Then now we got that right. Okay. Now the next question asks us that what user accounts did the attacker target during this Kerberos attack. So going back to RDP connection, looking at the event details, the very top part tells us, the account information, and then the account name is what Corrado. So definitely this is the specific account that the attacker targeted. Okay, during the Kerberos attack. Let's submit that. Okay. What is the SID associated with the user? So keep this in mind. It asks for what the user account, right? So let's go back and look at what we have. Um, so we are basically looking at the account information again, okay, looking at the user ID. So this is exactly what is being requested for. Copy that and let's see if it works out. Oh, I think let me recopy. So I'll paste this here. So guys, do well to subscribe if would like to see more of the. I'm planning to also take up the various challenges, okay, with regards to AD, that's Keberstin, NTLM relay, golden ticket attacks, the rest. So and then kindly leave a like as well if at least this was explanatory enough for you to understand. Because you are not just solving the challenge, we need to understand the logic behind, okay, what is really happening, so that we can't be able to confidently say that yes, we are, solving the challenge, and then not just, coming up with, answers, but we indeed understand what is being done. Now, what encryption algorithm was used in the Kerberos ticket request? I told you about this. So the encryption algorithm that was used, we just look at the ticket encryption type. Okay, 0x17 is the standard AES 256 encryption. Okay, and for sorry 0x12, okay, is the standard AES 256. But when we see 0x17, it basically uses the legacy RC4 encryption type. Okay, but if you would still need to confirm this, okay, so let's just use Google and then see. So you are being asked that what was the encryption algorithm, this Kerberos ticket request. So what I'll do is to go back. So yes, so I'll just put in this the what encryption type. Okay, and let's see what it tells us. So the encryption type code 0x17 in Kerberos stands for what, RC4 H mark. Okay, so this is some details as well that I pulled up. So just as I said, this is RC4. Okay, so bear that in mind. Then what is the IP and then port number that was used to request the ticket? So we are basically looking at the attacker. Okay, let's go back to the log and scroll through there. So at the network information level, we can't be able to see the client address and then the client port. So I would copy the address. So I think we need this, right? And then we need a port as well. So I would paste the one at a time. So I think the copying didn't work. Go back. This. So remember, wow. Let me just so 192.168.110.1.9. So 168, 110, 129, and the port, let's see, 49684, 49. So we got that as well. Let's move on. Um, the attacker managed to crack the hash and then used it to log into the compromised machine. So compromised machine we are looking at here is that of Corrado, right? Which we found over here. So this is the user account that's the attacker targeted, right? When was their first logon attempt? Okay, so right now we want to look at uh, uh, we want to shift our focus, okay, in terms of the event IDs, look at 4624 because any event with regards to a successful logon, okay, is um uh is recorded, okay, with the event ID 4624. So I think that we are going to filter for the event ID 4624, and I think so the attacker managed to crack the hash. When was that? So I think what will help us to identify this exactly would be a successful, logon event. Okay. That event ID 4624, and also the attacker's IP, which we found over here, and perhaps a logon type would also tell us, especially a logon type of 3 would tell us that this was done over the network. And I think, yeah, I think for now we can't use that, right? And we also need to note the time. So this was the time, the this was the time the ticket was requested for. Okay, so that was at 2:42 p.m. So it means that um what we are looking for over here has to be after 2:42 p.m. Okay, so let me go back to the event log and now filter for um 4624, 464, and the time we're going to set a custom range, right? So wow, let me quickly check. Let me quickly check the exact date of this event. That was on 10th May 2024. 10th May 2024. So 10th May 4 at we are looking at events after this specific timestamp, that's 2:42 p.m. Okay. So I can make this maybe 2 40 p.m. Okay. Then the last event can be um up to can use the same date, uh day 24, and perhaps 11 um 59 p.m. Then I click on OK. Uh Sorry, we need to re-specify this. So 464, 46, sorry, 24 exactly. Then I hit enter. So let's see what we have here. Um so we have events dating um uh okay, in terms of the time, this is around 6 p.m. So we need something as close to 2 p.m. Uh let's see what some right. I think this is so we are looking for events after 2:42 p.m. right? So this is 2:42. Okay, so it's a logon event. Um and let's see what we have here. So a new logon. I don't think this is what we are looking for. Especially we are also looking at the logon type, okay, which is done over the network. And no, we are also looking for Corrado. Okay. And or do I just use one of Eric's tools pass the logs so it makes it easier? Let's just see. Um just see. So this is still on the Sopranos. Um so okay, account name is Corrado can be uh so you see this source network address differs from the one we found earlier on. So what we found earlier on was the attacker's address, that is dot 129. Okay. And this was a um let's see, yes, it was a logon process, but this is not what we are looking for. So let's keep. Okay, right. So you know what? Let me just instead of manually looking through this, which could be you know, uh quite difficult. Okay, let me just so let me maximize this, see if I can actually, let's see what tools we have for it's a couple of tools. Okay, yeah. So Eric Eric's tool. I think we can make use of this tool. Can make use of pass the logs so that finds this. Yes, we are going to make use of this um just so that, so I'm going to open this. I have to open this in PowerShell actually. Let's open Shell. As an administrator, open it as an administrator. Okay, and so we are in um system 32. But let me quick. Okay, let me double. exactly, it worked out. So dir, let's see what we have. So exactly, we have the two over here. So what this two would help us to do would be to pass the domain controller logs. Okay, because right now we are looking at identifying um let me go back to the we are looking at identifying the first logon attempt, okay, by the attacker, right? So the first logon attempt, you are looking at a timestamp after 2:42 p.m. as well, and then also a log that contains the specific IP address of the attacker. So you are just going to use this to pass the logs. And what I also need would be the path to the log file. Okay, so I think let me go back to challenge file. That's right. So domain controller logs. Okay, so no, why don't we rather use the endpoint logs? Okay, because if you are looking for the timestamp at which the user, okay, logged into the specific um, account which they um, successfully gained that um, um, encrypted hash from and then cracked it offline, we definitely need to look at the logs on Curado's system. Okay, so yes, I'm glad I got to identify that on time. So what we're going to do is to look at these logs. So either we open it in events viewer or perhaps we can still go with the parsing. So after we parse it, it will become a CSV file, and then we can't be able to um, look at it using the timeline explorer. That becomes so much easier. I think I've solved some challenges, while I used this specific approach. Okay, that was on memory analysis. Okay, and I think it's quite cool. It's very very much cool. I think I'm going to use that same process over here. So what I'm going to do is to copy this part. I'm going to copy this part. So this is the path to the log file. That's the end users log file or the log file located or derived from the specific targeted account. So let's start off with specifying the two. If auto completion works out. If it doesn't work out, this is the exact tool we are using. So EVTX, sorry, EVTX, ECTX. Okay. Now, after we specify the tool, we'll now specify the path. Okay, so I'm going to use this, specify path. So this is the path we are going to look at. I think how to .evt. So this is the path to the log file. Then another thing we specify is so dash dash CSV. Then we'll specify the location where um the parsed file is to be saved at, okay, as a CSV file, right? So I'm still going to specify it to be saved within the same logs where the security events logs was found. And I think that we can now specify um so CSVF. So how do we name this? We can name this Corrado uh dot CSV. Okay, so let's run this in. Okay, so it's actually running, and then you can see processing um the file, right? Um so the person worked out within 7 seconds. That's how fast it is to pass the logs. And you know, yes, so basically we've been able to pass the logs. What I'm going to do, so let's first verify, right? Let's first verify if indeed we have the CSV file that we know. Let's see, this is the DC logs. No, let's look at that of so you can see we have corrado.csv. Okay, so we are going to use Timeline Explorer to open this file, and this is Timeline Explorer, um, which has been should I say pinned to the task bar. We are going to open it. So yes, this is the interface you see once you open the Timeline Explorer. So then we go to files, we open, then we specify the CSV file. Okay, challenge file, ASREP, uh, Corrado, logs, uh, yes. So this is the CSV file. Then we would open it now. So this is the past version of the logs that we're analyzing with Events Viewer. So this becomes a bit simpler to use. Okay, so it becomes a bit simpler to use, like in terms of understanding what is happening visually. Okay, so what I'll do is to reduce this. Okay, because you are looking at a successful login event, that's 4624. Okay, so I'm going to find for that. And okay, so this is the event IDs. And what I'm going to do is to remove some columns that may not be of much importance to us right now. I'm going to hide this. I think what we need is the logon ID, especially this channel. um, Hide this column. We also don't need the provider, um the computer as well. We don't think we can hide this user ID. There's nothing. Okay, I think let's just keep that for now. I think, but I still think we'll process ID, hide that column as well. Definitely we know that event ID 4624 is a successful logon event, so we can just remove the level, just hide it. Event log record ID. I think we can hide this column as well. Username. In fact, we need the remote host than anything, because remember we have the IP of the attacker. Okay, if there was any logon event after the attacker was able to crack those hashes, okay, then trying to log into the system as Corrado, we'll still need so definitely we'll need the logon type to be three. That logon events, okay, happening via the network. Also need the payload detail. Let's see what else we put. um uh, yes, we also need a logon type, especially, right? So let me just remove this user ID column, hide this. I think user, let's just have it. Let's just have that. Let's kind of close the gap, and we need a logon as well. And aside that, there's also the executable information, um and I think the rest is data that we can ignore now. So having removed some or hidden some columns, I think we can now look out for the specific time. Okay, that's looking for the time that is back, make sure that you're on track. Okay, so yes, we are looking at 10th May 2024 around 2:42 p.m. 10th May 2024, and this is exactly. So yes, so so 2:15, 2:18, so 2:24 exactly. Um, okay, 2:42 rather. So let's just. I think over here would be cool. So at around we can look at, yeah, within this range you have 240, um yes, just to keep them marked, because if there was a successful log on event, it should happen okay after 2:42. Okay, so I don't even think that 2:40 might be of this, so we can remove that. So we are looking at 2:45. um let's just add a few more events and see if it's indeed tells us something useful. Let me scroll down a bit and let's observe. Let's observe this. So um, we can't draw conclusions, okay, in terms of suspicious events, but we can see that after 2:42, okay, um, specifically looking for this IP, that's the attacker's IP. Okay, the first event was at what 2:48 p.m. Okay, coming from this remote host, and it was an anonymous login event. Okay, with logon type 3. Yeah, I think we can even ignore these two events since they are of logon type 5 because you are more interested in logon type 3. Okay, and so this was an anonymous login event that happened, which means that the um this specific request, okay, um or here in authentication was granted, okay, as an anonymous user, okay, rather than authenticating as a specific user, maybe Corrado that we are dealing with over here. But let's also note that Windows, internal processes may also, generate some kind of anonymous login events, which may happen from time to time. But um, the reason why this could be suspicious is because of the remote host, okay, being the attacker's IP that we found earlier in the logs, okay, and this was an anonymous login event, okay, with a log on type 3. And so let's see if this works out. Uh, let me copy this and see if it out back. So I think we are going to use the same um approach. So let's see if this works out. Exactly. So right, that was exactly the first logon attempt. Okay. But because looking at the question, it asks us that what the attacker managed to crack the hash and then used it to log into the compromised machine. Right. So isn't the once you have hash, you've cracked it, okay, you've been able to access the user's password. Why log in anonymous? Okay, so I don't know, it doesn't quite sit well with me. Okay, because yeah, going back here, you can see the attacker. Perhaps okay, perhaps the attacker was performing some kind of reconnaissance activities. Okay, so perhaps after the attacker or logged into the system anonymously, you can see the second logon event was at 250 before now the attacker, okay, logged into Curado's account, right? And even that, yes. So yeah, before the attacker actually logged on to Curado's account. So I think if this question was to be asking, um, um, if it wasn't, asking for the first logon attempt, and it was just looking for the logon attempt to the the affected user's account, okay, I think this particular timestamp would be what we'll be looking out for, right? So let's just move on. Wow, we are almost done. So once inside, the attacker began exploring the system. What was the first command they executed? Wow. So I think whilst I was looking through the challenge file, I saw some prefetch files. I don't know if prefetch folder or something. Let me check again. So Curado, yes, exactly. So we have some prefetch files. Okay, okay, okay. Then I think we can't be able to answer this question using files. Okay. So basically, Windows prefetch files will help us to investigate the execution artifacts. Okay, like the commands executed. Okay, then we can't be able to actually. I'm confident that that will help us to answer this specific question. But even with that, we still need some tools, just like we used the other two to parse the event logs. I think we'll still need to rely on um, uh, one of Eric's tools to also do this. Okay. So you can see all the prefetch files are in .pf. So this is a special, compressed form of prefetch files. Okay, so they are really stored, in a compressed format, and then which makes standard text viewers, okay, not be able to see what is contained with, because it will just return everything as binary data. So let's even try opening in let's use notepad and then see. You'd see that you wouldn't be able to understand anything that is in a binary, right? But we can be able to make use of this um, these prefetch files, okay, by first passing them. So we are going to pass those logs, and I think we can be able to use the prefetch explorer. So by Eric again. Let me make sure it is here. Prefetch explorer, prefetch, uh, yes. So yes, so this is the exact application that we need, okay, to pass prefetch logs. So we have to actually look at the, since it's not just one .pf file, we have to look at passing the entire prefetch folder. Okay, so what I'm going to do is to although open this, I'm going to take note of this particular part and go back to my PowerShell. So yes, go back to PowerShell and okay. So I think I'm now going to come out of this directory and I'll use the PEC. That's auto complete. So no, not the DLL, the EXE. Okay. So after specifying that, just like the parsing we did for the security event logs. But since these prefetch files are stored in a folder, we are going to use the dash D, specifying the exact directory we want to work with. I'm going to paste directory name or the link to directory or the path, just to see. And so after specifying that, I think my um, CSV comes. So where I'm going to save the typo. I think I can save it within that save. So not to save it within privilege, but I think Corrado would be okay. So this specific folder would be okay. So literally, it would be saved open. Uh, so literally, when we are done, we expect to see the CSV files over here. That's what it means, right? We are going to save it into this specific directory. But we are not done with the command. We also need to specify the format CSV. Then how do we want to, sorry, CSVF, how do we want to save it as? So I want to save it page uh dot CSV. Okay, I think we are good to go. Hit enter, and yeah, it is doing what it's supposed to do. Right. So let's wait a while. See. Let me just make sure. Yes, so it says that what CSV output would be saved to the specific directory, like I told you earlier on. Then the CSV timeline output. So this is what we are looking out for. So it's the timeline outputs that we are going to visualize within Timeline Explorer. Okay, because that is what would tell us the information. Okay, it'll help us to easily visualize the information with regards to the specific commands that were executed. So right now we are going to note, the timestamps that we have, right? The first timestamp is what, at 2:42. Okay, that was when the ticket was requested. Okay, let me say the Kerberos TGT request was made. Okay, at 2:42 p.m. Then approximately 6 minutes after was when the attacker, okay, um after cracking the hash, tried to log on to the system. So that was 6 minutes after requesting for the ticket. So this was done at 2:48 p.m. And so once the attacker was inside, they began exploring the system. What was the first command that they executed? So literally, we are looking at a time range after 2:48 p.m. I hope you got that. Okay, so let's go back, and since it's done, we can now open Timeline Explorer and uh, go back file, because we're going to open the prefetch file. So I told you it would be saved over here. So we are looking at the timeline CSV file. Then open it. Then so this gives us some information like the runtime and the executable name. Okay, so this will give us at least the commands that were executed. Then we are looking at the timestamp, that's after 2:48. So let's just, why have to, I think I need to okay, let's just get a way. Yes, so let me sort the time. Then uh exactly, we are looking for time ranges past, that's past 2:48 p.m. So 2:48 p.m. starts over here. That's we are looking at something, am I right? 48 p.m. Let's see, this is now. Okay, so I think we are just looking for the commands that were executed after 2:48 p.m. That's after the attacker had logged into them, right? I think uh, let's see what we have. The various executables. This is what we are trying to look at. This definitely is from the Microsoft work, and if we need commands executed. So I'm trying to push my attention to anything that use the legitimate CMD. Okay, so looking at that, I think these specific executables are not something that we might. But okay, we have CMD exe over here. Um, let's see. That was at 247. Let's see if perhaps the attacker managed to enter in some commands via the command line. Um, that was system head. Um, um, we have another CMD um, going. We open it. There's also another CM. Wait. So there's also who am I kind of thing. This is interesting because who am I is a legitimate Windows utility that not even Windows because we can't be able to um, um, use it even with the Linux systems. So it's a utility that helps to identify a user's identity or even privileges. So just like in uh, penetration testing engagement or if an attacker is able to get initial foothold on your system, definitely one of the very first commands um they would like to execute would be who am I to check the kind of privileges they have or who they have actually been able to log in as. Okay, so let's say the attacker was able to escalate his or her privilege. Okay, so from a user account to the root user, who am I would be able to give that attacker that information they need, okay, about who is currently logged into the system. So this makes sense because aside that, let's just see. Aside that, I don't think there is any utility that you know. I think there's PowerShell. But you know what? Let's first submit this and see if because I'm honestly sure that who am I would be something that an attacker would first to execute if you had a CLI. So let's go back to and even with the exam sorry with the answer format it looks like it would still have the length of who am I. Let's see. Good. Exactly. So just as we identified, that was the right command that was executed by the attacker. And when did the attacker execute this? So we are basically looking at the timestamp, right? We are just looking at the timestamp. So I'm going to copy this and um, let's see how it goes. Let's see. Let's see. Exactly. So uh, right, we've been able to solve this challenge. It was really fun. It was really fun solving the challenge, and then this helps this helps anyone to understand the kind of attacks against Active Directory environments or that undermines Active Directory security. Okay, and also what we can be able to do against these attacks. The one thing to as a defender, one thing that might or not like might be necessary or that has to be done, okay, is to make sure that um pre-authentication is not disabled, right? Because it is the first thing that enables this ASREP posting. Okay, so we need to make sure that user passwords are extremely long and then secure. Okay, so that even if the case whereby there was an ASREP roasting attack, okay, it becomes a bit challenging for the attacker to crack those hashes. Okay. Then the secondly, to make sure that the pre-authentication is always enabled. There must be no need for pre-authentication at any point in time. Yes. So thanks for staying around. Thanks for watching the video. And I hope that this wasn't some kind of a walkthrough that just shows you how to answer the questions, or um just presents the questions to you, but also I try to make you understand from the Active Directory point of view, understanding how Kerberos the authentication works with an Active Directory environment. From there, we were able to look at how ASREP wasting occurs, okay, whereby the client, okay, does not have pre-authentication enabled, or pre-authentication was disabled for that specific client, for which reason an attacker having a list of usernames can be able to request a TGT from the authentication service, right? Which becomes a challenge with real world Active Directory environment. So thank you very much for staying around to the end, and I'll see you in my next. Bye for now.